You're watching the Central Post. This is Samiksha Ajay. And today we are talking about one of those discoveries that truly blur the line between imagination and reality. The 2025 Nobel Prize for Physics. This year, it's been awarded to John Clark, Mitchell H. Devoret, and John M. Martinez for doing something so great that sounds exactly straight out of science fiction movie. They brought the invisible quantum world visible to human eye. And the Nobel Prize Committee called it exactly what it is, bringing the quantum world to human scale. Let's decode what it means. In our everyday life, physics works just as we expect. If you throw a ball at a wall, it bounces back. If you push a table, it moves. Everything just makes sense. Because in classical physics, things move as they should. Simple, predictable, and logical. But at the atomic level, the rules are completely different. In the quantum world, a tiny particle can actually do the impossible. It can pass through the wall instead of bouncing back. And this strange effect is called quantum tunneling. Now, for years, scientists could only see this in atoms or subatomic particles, things far too small to even imagine directly, let alone watching them with naked eye. Then, the bigger question was, can we ever see this quantum behavior in something larger, something built by humans, something real and measurable? That's where these three Nobel scientists, Clark, Devereux, and Martinez came in. They worked with superconducting circuits, materials that carry current with zero resistance when cooled near absolute zero. In these circuits, electrons pair up to form copper pairs. Billions of electrons moving together as one unified quantum system. Just imagine that. Billions of particles behaving in perfect sync, like a single giant quantum particle. They then place this inside what's known as Josephson junction. This is a kind of barrier that electrons can't normally cross. But to everyone's amazement, this system tunneled right through the barrier, proving that even large, human-made circuits could show the same quantum behavior like an atom. This was the very first time that macroscopic quantum tunneling was observed, meaning quantum physics is no longer about the microscopic world. But their experiment didn't stop here. They didn't stop here. They wanted to test if this system could actually follow all the quantum rules, especially a rule called energy quantization. In simpler words, in quantum world, energy doesn't flow continuously. It comes in certain packets or levels. So the scientists sent microwaves of different frequencies toward their circuit. And what they found was something so amazing. The system only absorbed energy at certain frequencies, just like atoms do. And that was the proof. Their circuit behaved exactly like a quantum atom, even though it was visible, measurable, and human-made. And this is where things get exciting. Their discovery laid the foundation for today's quantum computers. Those superconducting qubits used by companies like Google and IBM, they exist because of these experiments. Google's Sycamore processor, which made headlines for performing tasks faster than classical computers, uses circuits inspired by this very research. Beyond computing, their work is helping build quantum sensors, ultra-sensitive measurement devices, and technology used in navigation and astronomy. So when we talk about the future of technology, ultra-fast computing, secure data, quantum communication, it all connects back to the physics these Nobel laureates uncovered. These findings connect the bizarre world of quantum physics to everyday technology. Scientists have gone from studying tiny particles to using them in devices we can hold. It's tough work. Quantum systems need super cold temperatures and protections from any noise. But researchers keep improving it every year, laying the foundation for future innovation. The 2025 Nobel Prize in Physics celebrates curiosity and imagination, turning quantum mysteries into real-life technologies. It shows how science is not just about space and stars, but also about exploring hidden worlds within everyday things. Keep watching the Central Post for more such content.